Hello everyone, I'm Colin Kurz, and this is my report for Lab 3. The purpose of this lab was to analyze the magnetic field created by a small bar magnet as it moved relative to a magnetometer. A glow script model was made to model this behavior. The lab also demonstrated the distance dependence of a magnetic field and compared experimentally gathered results for a bar magnet's moment and magnetic field at a point 45 degrees from the phone to that of the computational model. Some results from the lab are shown on the screen. The fundamental physics principles of this lab depend on the idea that bar magnets behave like magnetic dipoles. The Biot-Savart law was used to measure the strength of the magnetic fields on axis with the magnet and used to find the magnetic dipole moment mu. The distance dependence formula was used to find the distance dependence value n using the constant k, magnetic field strength b bar, and distance r. The formula for off-axis magnetic field was used to find the strength of the magnetic field at the off-axis point. In this lab, the system was the phone magnetometer, while the surroundings were the Earth, magnet, and any ambient electrical or magnetic interference. Before the lab, the phone had to be lined up north along a ruler to ensure the Earth's magnetic field would not interfere with the results. Then, the magnetometer in the phone was located by finding where the maximum values of magnet strength in the phone were. The magnetometer was lined up with the ruler with the magnet on the end. The magnet was moved along the ruler until the strength of the field in the x direction reached certain values, at which point the distance between the phone and the magnet was recorded. This procedure was repeated for each desired field strength 3 times. These results were averaged for a more accurate overall result. The phone was then moved a distance where the strength of the field in the x direction was 100 microteslas. It was moved up the same distance that it was away from the magnet. The magnetic field at this location was recorded 3 times, with the average of these results being taken. In Excel, the magnetic field in the y direction due to Earth was taken away from this result to ensure accuracy. This is the data used to calculate values in the rest of the lab. Some functions, such as the calculation of the net electric field at the off-axis point, were performed automatically. An important observation is that the magnetic field strength was, as expected, inversely proportional to distance. These are some calculations used to find the distance dependence relationship and the magnetic dipole moment using the results from the last slide. Importantly, the measured distance dependence relationship was off from its theoretical value of -3. The observations stated on the last slide are also elaborated on. In step 1, the magnet was created in a code, and a function to calculate the strength of its field at any point in space was using the off-axis magnetic field formula was created along with it. In step 2, arrows were created at several points in space to represent the strength of the magnetic field at those points. The strengths were calculated using the formula from step 1. In step 3, the average perpendicular distance from the experiment and the function from step 1 were used to calculate the strength of the magnetic field at the point 45 degrees from the phone. The results from the glow script were all from observed values, but not by much. This speaks to a well-conducted lab and accurate code. However, there may have still been several errors. An obvious source of error in this experiment is that the phone may not have been aligned correctly, or some magnetic field calculation from the Earth may have been wrong. Some final questions remain. For the first question, the phone pointing north meant only that the y component of the Earth's magnetic field interfered with measured values. It would have still been possible to conduct the experiment with the phone tilted differently and get the same results, but it would have required more calculation, particularly subtraction of the Earth's field from results. For the second question, sticking two magnets together would not change much direction-wise, as the two magnets would act as one dipole, like the singular magnet. However, the strength of the field would relatively double, as the strengths of the two magnetic fields would be combined.